Welcome to part 2 of our introduction to structures. For this lecture, all we're going to be looking at then is we'll do a real quick review on the structure themselves and how we define them, and then use them in our program, and then we'll look at using structures as arguments to functions. So let's go ahead, and I actually have a few slides here. Same slide deck that we used for the first lecture. We're just going to look at just a couple of them here. So structures and functions. There is 3 ways we can look at passing structures around to functions. One is that we don't actually pass the structure itself, but we pass the member. Okay, if we pass the value of a member, then we're just essentially passing, a value of that data type. So if we have a member that's an int, we want to just pass that member itself as an argument, the value to an argument to a function. We just pass it as an integer value, and I'll show you that here in just a second. The other 2 ways then is that we pass by value and we pass by reference. Okay, so we've talked about that back in the introduction and the review when we talked about functions. We can pass by value, we can pass by reference. We can do the same thing with structures. Okay, when we do pass by value, there is quite a bit more overhead. Although it's pretty negligible in terms of our small programs. But when we pass by value, then that creates a copy of that entire structure. These structures, because we can have multiple members, and there is more memory that we're going to allocate for those. It's a little more overhead with them. When we pass by reference, we pass it as we have with others, like other pass by reference. Okay, we can just declare a pointer, an argument, as a pointer type pointing to that structure. Okay, so it's very similar. We're just working with structures instead of the other types that we have. So let's see here. Go to the next slide. Array of structures. We're not going to worry about this. Okay, again, you can declare an array. Okay, so let's say we have cards, we declare it a size 50, and then those elements will have a type of struct card. But we're not going to worry about that. That won't be in the lab. That won't be on a quiz or an exam or anything. And then there is a practice. I have this uploaded. This is the practice. So if you wanted to go through, first thing would be to create a structure with the following members: a char for first name, a char for last name, and then an integer for student ID, and a char for gender. Then the next part of the program would be to initialize that structure and print off all of its members. All right, and then you can follow the second portion here. So if you want to, if you're not feeling real comfortable with structures, go ahead and work through the sample lab, send it to me, let me take a look at the code, and I can send you or provide you with any feedback based off of your work there. All right, so back to the code then. All right, this is the same code that we looked at in the last lecture. We're just going to build upon it. So keep in mind we had 3 structures that we defined here. Okay. And let's just start off with, again, good reminder is don't forget your includes. All right, so we're working with strings. I'm going to include string.h. 3 structures. Okay, card, employee, and employee2. All right, for the functions, we're not going to worry about card. Okay, so you can kind of forget that that was there for the time being. But we are going to use employee2 and employee. Now, the difference between the 2 is our first 2 members, the members for first name and last name. Members are just the variables for the structure. Okay, they're just a little fancier way. When we say member, we know we're talking about a variable inside of a structure. The difference then between these 2, okay, these are char pointers, and these are char arrays. Okay, and we talked about the considerations here in this sample program, right? So if we wanted to use arrays, then we need to use string copy. All right, and if you're not sure exactly what I'm talking about, go back and watch the earlier lecture, the lecture for the introduction, part 1. I guess we could call it that. Let's see. Okay, so those are our 2 structures, employee and employee2. Those will be the 2 that we're using for our 3 functions that we're going to look at. All right, 3 functions. Okay, so print employee2, and then we'll look at print name. And these will cover the 3 ways that we can pass structures around to our functions. The first one you can see here is that we have 1 argument, and it's going to be passed by value. Right? We're going to pass. We're defining this argument as a non-pointer. Right, so that when we call this function, we pass by value and we create a copy of that structure in this argument and then we use that copy inside of the function itself. For print employee 2 then, this is going to be a pointer. Okay, so this is how we define a pointer as an argument. Okay, it's just like we define every other type of argument, other pointer types and other non-pointer types. We're just using our struct employee. Okay, so it's just a difference in the type. You know, it's a derived data type, and we have to make sure that we define it as such. The last function then that we'll look at will be print name, and this is just to show you an example of how we could actually pass a member of a structure to a function instead of the entire structure itself. Okay, so if you just need a certain member, you can just pass that member itself and not the entire structure. So here we'll have 2 arguments, 2 char pointers, first name and last name, and then that will just print off one or the other. However, we'll take a look at that in a second. All right, so scroll down to the bottom of our main function, and let's see here. We have a employee. All right, so this code gets a little bit discombobulated, but keep in mind or go back and recall we have our employee. So a employee, that's not a pointer, so that's just a variable of struct employee type. We use the dot notation. Okay, so the dot operator to access each individual member. Remember, we use the dot operator on non-pointers. This is not a pointer, so we can use the dot operator. So use the dot operator, access the members, and then we can assign a value. First name and last name on our employee struct, these are char pointers. So with a char pointer, we can assign a string value directly. The rest of these are primitives, an int, a char, and a double. All right, so there's our a employee. Tell you what, I think this is a little confusing, so let me, you know, we're going to need them all, so we'll just leave it there. I don't want to disrupt it. So we're going to use that employee, that a employee variable, and we'll pass it as the value to the one and only argument for our print employee function. Okay, that argument is not a pointer, so we don't have to provide a pointer. What do we do? Arguments that are pointers, they expect a memory address. Since this is not a pointer, it doesn't expect a memory address. It expects the variable itself. This is passed by value, so it's going to create a copy of this a employee variable, okay, which is all of these members and all of that data. Makes a copy of it inside the function, and then we can do whatever we would normally do with the structure inside of there. So we'll go down here and we'll look at print employee. Okay, here's the one argument. Argument is of type struct employee. We can call it a employee because remember, with arguments that are passed by value, they essentially become a locally scoped variable for that function. So in this case, inside of this function, then we could print all the members if we wanted, but right now I just have it printing first name and last name because I think you'll get the point or the idea. And because this is not a pointer, we use the dot operator. Okay, so a employee dot first name, a employee dot last name, and inside here we have a tab, format specifier for a string, and then our new line character. All right, and that's all it does. Okay, so if I want to pass by value a structure to a function, that function has to be defined to expect a pass by value or a variable, a non-pointer variable of that type of struct employee, and then we call that function passing the value of that variable. So we'll go ahead and we'll clear the screen here. We'll compile the program, and we'll give it a run. Okay, and there it is. It called it. We can see first name and last name, and it printed it off. Okay, just to reiterate, let's just go ahead and explore pass by value, pass by reference again, just in case maybe the idea or the concept hasn't quite stuck yet. So this is a local copy, right? We just made a copy of that variable. This only exists now inside of our function. Outside of the function, it doesn't exist. So if I change a employee, right, this is not a pointer, so I can use the dot operator, and I can say first name equals, and I'll call first name now in the function. And let's say now I want to print first name again. So now this function will print first name, last name, it'll modify the first name, and then it'll print the first name again. Whoops. What are we going to see when we call the code? We should see first name, last name, and then modified first name. And that's great. Okay, that's what we expected. However, if we go back to our main function, and let's say that we print, oops, that's not what I wanted to see. Let's say that we print the first name again. Okay, so I'll add a line here to print the first name. It's a non-pointer. It's a variable of the struct employee type. So we use the dot operator and we'll print that. So all right, and there's our output. Okay, so our function, this is the output generated by our function, first name, last name, modified first name, and then this is the output generated in main again. And you can see that it still has a value of Josh, right? It's passed by value. So when we modified that struct employee variable inside this function, the changes only existed here. Once we returned out of this function, we go back into main. This variable, that structure variable, has all the original values that it had when it called print employee. Okay, so that's an example of pass by value. Hopefully that's making sense. All right, I'm going to get rid of that. And we're not going to worry about this. And we're going to look at and move on to our next function. So, print employee 2. Okay, we don't need that output anymore from print employee. Print employee 2. So let's go look at the prototype. What is print employee 2? Well, it expects a pointer that was going to point to a struct employee. Okay, so now we're going to explore the pass by reference. Since it's a pointer, what does a pointer expect? It expects a memory address. Remember, we can use the address operator on our struct variable types. So with this one, we don't have to declare a pointer to pass a pointer to it. We can just provide a memory address. So print employee 2, go down and take a look at print employee 2. Okay, same exact thing. The only difference here is that this is a pointer. Okay, and just like in the last lecture when we looked at the difference between variables of struct employee type and variables that were pointers that were pointing to struct employee, we have to use the arrow operator. Okay, otherwise it's exactly the same. Okay, this is a pointer, so we use the arrow operator. This is not a pointer, so we use the dot operator. So with this code now, when we run this program, we'll see that we're using the same employee variable, so same values that we were working with in the last function call, but we're going to pass by reference. All right, so pass by reference, we're not making a copy. We're pointing to referencing those same places in memory. So we'll clear the screen. Okay, good. No errors or warnings, and we're going to run this, and you'll see same exact output. Now, pass by reference. Okay, so this is a pointer. We have a memory address, and now we're pointing to the same places in memory that these members were originally assigned. Okay, when variables of any type get declared, they get assigned a memory address. And pass by reference means that with this is pass by value, we had a copy of it. This is pass by reference. We're still pointing to that same location. So if I change the value, let's say I change first name and I set it equal to in the function. Now if I print here, we're going to see, just like we did in this last function, if I print first name after doing that, it's obviously going to print in the function. Okay, so I'm not going to do that because we know that to expect that. However, what if I print, I should have kept that instead of deleting it, but what if I print the first name after the function call? So set that up and we'll print the employee dot first name. Right? This is not a pointer. Back in main, this is not a pointer, so we're still going to use the dot operator. Okay, so we'll compile this code. And there's our output. All right, so this is the output generated by the function, first name, last name. After we generated that output, we changed the value of the first name, but we didn't print it. Okay, we returned back to the main function, and now we printed the first name. Okay, and you can see that that change was a global change, right? Pass by reference. That means that we're changing those members globally. We're still pointing to those same exact places in memory and modifying there. Okay, this is not a copy inside this function. It's not a copy because it's passed by reference. Okay, so that's not only just kind of a review on pass by value, pass by reference, but also gave us the opportunity to explore structures as function arguments. Okay, so this is pass by value, and this is our pass by reference, right? And those are the differences. Okay, I'm going to go ahead and get rid of that. Hopefully I don't regret it. Okay, the last thing we're going to do is, of course, if we declared a pointer, then, which we did here, okay, we declared ePointer to be a pointer that's going to point to a struct employee, and we initialized it to the memory address of the A employee variable, okay, using our address operator. So that means that if we call print employee 2 and we want to use a pointer, then we just pass the value of the pointer. Remember, the value of a pointer is a memory address. Its value is the memory address of A employee. Okay, so this is essentially the same thing, except that we're using a pointer. Okay, and so we'll just compile that program, and you'll see that the output's identical. Okay, first name and last name. All right, and then this last bit of code was actually some remnants. I haven't deleted it, but that's just going through changing the members, accessing the members using the arrow operators. I put this there after we went through the functions, and before I realized, or I just didn't realize at the time, that we need to talk about the arrow and the dot operators before we talk about the functions. So there's no reason to go through this code. It's already stuff that we've covered. All right, the last thing that we want to do is we'll comment that out, and I'm going to look at print name. Okay, so what was our print name function? Well, go back to the prototypes and you'll see that it prints, it's a function that has a return type of void, 2 arguments, 2 char pointers, first name and last name. Okay, if we go back down into main, then we'll call print name, and those 2 arguments are char pointers. That just means that I have to provide char pointers. Okay, we know first name and last name are char pointers, so we can just we can access those members directly. Okay, ePointer is a pointer, so we use the arrow operator, and that will pass the member directly. Okay, so if we look at print name function, okay, I'm just because I'm just going to print the first name. Okay, so first name tab, the name itself, and then the new line and the first name value. Okay, all right. So when we run this program, you'll see that just the first name will be printed. And there it is, first name and Josh. Okay, we could also call print name and say A employee dot first name and A employee dot last name. Okay, same thing, right? The function doesn't care. Print name doesn't care because it has two arguments. They're char pointers. All it cares is that when you call print name, when you call that function, that you provide it 2 values that are char pointers. Okay, so strings. Print name, we can call it. When we use the arrow operator, when we use the dot operator, it does matter. ePointer is a pointer. Because it's a pointer, we use the arrow operator. If I tried to use the dot operator, you'd get a compilation error. A employee is not a pointer, so we use the dot operator. First name and last name are char pointers. Okay, so that's all we care. That's all print name cares about when you call it, is that you provide it as a value its data type. In this case, the char pointer. So that's it. That's really all there is to structures. I know this is quite a bit, so please I encourage you to take a look. Oh, I'm sorry. Let's actually look at the lab quick. All right, so we have about half of the pieces for the lab. The rest of the lab will come when we talk about malloc. All right, so the first part is understanding structures and how to use them. The second part then is understanding malloc. So this will give you an idea. Again, if you want the lab opened early, I have no problem doing that. I'm just holding off on opening it just to give you some time to not worry until that following week here. where we start talking about malloc. But no problem if you want me to open it up early, just shoot me an email and I'll get it open. The lab comes in 2 parts. Okay, it's a relatively straightforward lab, just using structures and malloc. Okay, so what you'll do is you'll create a structure, and the structure will have 4 members. 1 for size, 1 for time, 1 for file name, and 1 for type. Those members are defined up here in the instructions, so you can see the type and the size and all the elements that you'll need. In the main function then, what you'll do is you'll create a pointer to the structure. You'll malloc memory for the structure, and then you'll prompt the user, you'll prompt me, to read data in for your structure. So you'll say, as you can see here with the output, enter the type, enter the name, I'll type in D, I'll type in hello, enter the access time, I'll type in just some random number. Do not worry, I want to stress, do not worry about time. Time is just an integer. Don't worry about an actual time or date time object. Don't worry about any of that. Just make it an integer type. Enter the size is just integer type, and then you'll print off the characteristics or print off those individual members. So that's what part 2 is, right? One function that prints out all the contents of the file structure. That function will have 1 parameter, which is a pointer to the file structure. Okay, so that's all it is. Declare a structure, declare the members that match this type, use any means of getting from standard in values from the user to populate those members, and then have a function that has as its only argument be a structure type, and that function is where you print. Okay, so your main does nothing but capture. Your one function will be the one that prints it. We'll use malloc to malloc memory for the structure. Okay, and so once we get through next week and we get through malloc, you'll have all the pieces that you need to finish this lab. So hopefully it's quite a bit easier than the previous lab, the recursion lab, and kind of a good break. So, all right, that's all I have. Any questions? Let me know. Thanks.